Hello everyone, my name is Kevin Kotaria and this is my project presentation of my class EEE 236, that is semiconductor physics. So today I'm gonna talk on future memory technology, that is 3D Xpoint memory technology. The topics that I'm going to cover in this presentation is types of memory, the need for this new technology, introduction to 3D crosspoint memory technology, what's inside of this 3D memory technology, how does it works, advantages, disadvantages, and it follows by the conclusion. So my first topic in the presentation is types of memory. As we know that computer memory is divided into two types of memory, that is primary memory or volatile memory and secondary memory or non-volatile memory. So the volatile memories are faster but they needs constant supply. We can say it like volatile memories are very secure since it does not retain any records after power is removed, so no data can be salvaged. However, this acts as a double-edged sword. If there is a power interruption, all data is lost. So examples of volatile memories are DRAM, SRAM, and for non-volatile memory, they are bit slower as compared to volatile memories, but data stays in non-volatile memory without power supply. And the examples for non-volatile memories are flash memories, SSDs, hard drives. So why do we need this new technology? As the technology that we are using is very old. So this is the memory pyramid. You can see that the volatile memories are very closer to CPU, that is cache memories, and temporary memories, that is RAM, and the non-volatile memories that are very far from the CPU. So the NVMs are mainly SSDs or hard drives, and so the volatile memories that are very close to the CPU, but as whenever there is a power interruption, the data lose all the datas, and hence CPU needs something. CPU basically is dependent on the non-volatile memories, but as non-volatile memories are very far from the CPU, it slows down the performance of an CPU. So the non-volatile memory should be upgraded, or it should bring to the as close as possible to the CPU. So in this memory pyramid, we can see that CPU, the nearest memory to the CPU is the cache memories. They are all temporary memories, and they have also got three levels of more than one level of cache. And then comes the random access memories, which is volatile memory, which needs a power supply to access the data. And then comes the non-volatile memory. So as we saw in the memory pyramids, that volatile memories which are closer to the CPU, they needs power to access the data, and the non-volatile memories which are far away from the CPU, but they don't need the power supply to store the data. But as they are far from the CPU, it takes time for the CPU to access the data, and hence it makes the performance of the CPU a little bit slower. So hence that was that could be one of the reason to develop this new technology, which is 3D crosspoint technology. As we know that SSDs are transistor based memory, while this 3D crosspoint technology it's a transistor less system, and transistor less memory design. So we can say that this 3D Xpoint technology is a simple, it is stackable and transistor less design that creates fast, inexpensive, and non-volatile storage memory with low latencies. So like latency has the first priority when it comes to any CPU or data communication between CPU and memory pool. NVMs are usually slow, but nowadays like SSD are faster as compared to hard drives, but they are still slow. So this was one of the reason for developing this new technology, this new concept of 3D crosspoint technology. It's like it is highly endurance with the same storage density and faster accessible than NAND memories. So this technology has possibility of replacing the needs of NAND-based slow SSDs, and as this memory is 1,000 times faster than the NAND and it's denser than DRAM, it can also like there are possibilities of it replacing both kind of memories. So what's inside this 3D crosspoint memory technology? As you can see in the picture, it's like the base is metal, the second layer is selector, and the third one, yellow color, is memory cell where the data is stored. So as we can see in the picture, it's crosspoint architecture positions selectors and memory cells at the intersections of perpendicular wires. So each memory cell is able to access individually by a current sent through the top and bottom wires touching each cells. So the memory cells that are stacked in 3 dimensions to improve the storage density. So you can stack layers above layers to increase the storage density. Here the bit storage is based on a change of the resistance level and in conjunction with a stackable cross-graded data access array. How does this 3D crosspoint memory technology works? So this 3D crosspoint memory technology works on the changing voltage of the metal lines. The selector and the memory cell sits in between the word line and the bit line. So as we can see in the figure that each cell stores a single bit of data. A memory cell is made to represent either 1 or 0 through the bulk property change in the material of the cell, which changes the resistance level of the memory cell. This cell can either be a high or low resistance state, and changing the resistance level of the cell, it will change whether the cell is read as a 1 or 0. And applying voltage on the word and bit line, they can be accessed for read and write operations. Read and write operations can be occurred by varying the amount of voltage sent through the selectors. So for the write operation, a specific voltage is sent through the wires around the memory cell and selector. This activates the selector and allows the voltage to through the cell to initiate the bulk property change. And for the write operation, different voltage is sent through to determine whether the cell is in high or low resistance state. So this as we can see in the picture, a 3D structure can be created by stacking the single memory bits on each other to make memory more denser, and more data storage is possible by stacking more than one layer over another. That makes it as 3D crosspoint memory technology. The advantages for 3D crosspoint memory technology is it's very much faster than the traditional NAND memories. So 3D this memory technology packs lots of memory elements, which makes it cheaper bit and inexpensive. So like as we saw in the previous slide, that the stacking layers of single memory bits on each other, which could make the memory more denser and more data storage is possible. So this way we can reduce the cost and it becomes helpful to as less expensive. So it has got few disadvantages too. So right now it's on the testing level, and this technology needs to be thoroughly tested on each and every aspects. So like, as it is an emerging technology, it needs to be tested on each and every aspects. And as I said, it's like it's an emerging technology. It would face an hardware connectivity issues with the current technology, with the current processors. And so it it could face some hardware connectivity issues too. And thank you. So if you have any doubts or any suggestion, please comment below. Thank you.